Hello friends, welcome to the first video on Microprocessor and Microcontroller. This series of the videos will be basically for the subject Processor Architecture. So let's start with the first video. The objective of this particular video are to understand the difference between microprocessor and microcontroller. After understanding the difference between microprocessor and microcontroller, we are going to move towards the microcontroller, where we are going to learn the different criteria for choosing the microcontroller. Before going to the difference between the microprocessor and microcontroller, we will individually see what is meant by a processor and what is meant by a controller, that is microcontroller. CPU, nothing but central processing unit. If it is built on a single integrated circuit, that is IC, then it is called as a microprocessor. A microprocessor consists of ALU, that is arithmetic and logic unit, program counter, stack pointer, some of the working registers, a timer circuit for generating a clock, and interrupt circuit. The arithmetic and logical circuit unit will be responsible for performing the arithmetic as well as the logical operation. Arithmetic operation consists of subtraction, addition, multiplication. Logical operations are nothing but ANDing, XOR. These will be done in a microprocessor. The result will be stored in a working register. Now, a hardware design of a microprocessor CPU is arranged so that a small or a very large system can be configured around the CPU as the application demand. The prime use of the microprocessors are to fetch the data. The data is going to be saved on the external memory. There will be no internal memory for the microprocessor. So the data will be fetched from the external memory. Second task, to perform the calculation on the data. As we said, any kind of the arithmetic as well as the logical operation will be done in the microprocessor. After performing the logical as well as or any kind of a arithmetic operation, that calculation is going to be saved on the external data, and those results will be now used by the human. The program used by the microprocessor are stored in a mass storage device and loaded in a RAM as per the user requirement. A few microprocessor programs are stored in a ROM also. So as I said, in case of microprocessor, there will be no internal memory. Whatever the memory is there, that is external. The program as well as the data will be saved external to the microprocessor, and whenever the microprocessor need to read these data or need to fetch the data, or if you want to execute any kind of a instruction also, at that time also he has to take that instruction, he has to fetch that instruction from the external memory, and then he can perform the specified operation on that data. Now, after learning the details of the microprocessor, let's see the block diagram of the microprocessor. As we know, the different components which are there in a microprocessor, those are arithmetic and logic unit, accumulator, working register, program counter, stack pointer, clock circuit, and interrupt circuit. Now, we know that there are many types of a microprocessor, like 8-bit microprocessor, 16-bit microprocessor, 32-bit microprocessor, and so on. Now, who decides the size of the microprocessor? So, arithmetic and logic unit, the unit which performs the arithmetic and logic operation, will decide the size of the microprocessor. If your arithmetic and logic unit is 8-bit, then that microprocessor is called as the 8-bit microprocessor. For example, 8085. If this arithmetic and logic unit is 16-bit, then that microprocessor is called as 16-bit microprocessor. For example, 8086. If this arithmetic and logic unit is 32-bit, then that microprocessor is 32-bit microprocessor. For example, 80386. So depending upon the size of the ALU, it again decides the size of the data bus. It will be same as that of the size of ALU as well as the size of working register. So I can say that in 8-bit microprocessor, you will find almost all the working register of the size 8-bit. Similarly, in 32-bit microprocessor, you will find almost all the working registers of the size 32-bit. Now, the program counter. The program counter is one of the registers which holds the address of the instruction which is currently going to be fetched. Currently going to be fetched means the instruction address which I am going to read next from the memory. I will repeat again. The memory is outside to the microprocessor. You can see that this is the architecture diagram, or this is the block diagram of the microprocessor, where I have not shown the any kind of a memory component, because for microprocessor, memory is external. It is not the internal part. Whenever I say the microprocessor is packed in a one integrated circuit, that is in an IC, then I have to interface the external memory to the microprocessor. So, the instruction which I am going to fetch from the external memory, the address of that instruction will be saved in the program counter. One thing I want to note here, or one thing I have to tell, and that is, if a program which is running on 8085, that is nothing but your 8-bit microprocessor, the same program can run on the 16-bit microprocessor. The reverse is not possible, but I can always run the program which is running on the lower microprocessor on the upper microprocessor. That's how the working registers are arranged. Or I can say that in case of 8086, you will find the registers are 16-bit, but I can use them as 8-bit also. For example, AX register. AX is nothing but an accumulator register, which is a 16-bit register in case of 8086, but I can use it as AH as well as AL also. Why it is so? Because if any program which is running on the lower microprocessor, the same program can run on the upper microprocessor. The reverse is not possible. Now let's move on to the next one, that is introduction to the microcontroller. Now as we see, in case of the microprocessor, the main units are ALU, PC, that is program counter, stack pointer and register. All these features are available on the microcontroller. Then what is additional with this microcontroller? Then the additional to this microcontroller will be a ROM, a RAM, the parallel ports, some of the serial 110 ports, counters and the clock circuit. This will be the additional to the microcontroller. Now, like a microprocessor, a microcontroller is also a general purpose device. The prime use of a microcontroller is to control the operation of a machine using a fixed program that is stored in a RAM and that does not change over the lifetime of the system. So, the major difference between the microprocessor and the microcontroller is the memory. Obviously, some other major differences are also there, like a timer, the counters, which are internal to the microcontroller. But one of the noticeable difference between the microprocessor and microcontroller will be the existence of a memory on the chip itself. The microcontroller design use much more limited set of single and the double byte of instructions that are used to move code and data from internal memory to the arithmetic and logic unit. And that is the difference lies between the microprocessor and the microcontroller. As I said, whenever I have to fetch or read any instruction for the microprocessor, I have to first place the address on the address bus. That from the program counter, that address will be placed on the address bus. That address will be given to the external memory. Then the opcode of that particular instruction will be placed on the data bus, and that's how that particular instruction will reach to the microprocessor. But in case of the microcontroller, now whatever the code is nothing but your program, and the data is present internally, and that can be taken internally. So this is the block diagram of the microcontroller. You will find the similar elements which are there in the microprocessor, in the microcontroller also, but some of the additional elements are, or some of the additional blocks are the internal RAM, I/O ports. I/O ports are nothing but input-output ports, which are the programmable ports. I can program them according to my requirement as an input port or as an output port. That means in between of the program also, if it is needed, then I can program them as an input also or as an output also. Timer and counter and the internal ROM. So you will find the difference between the microprocessor and microcontroller with this one. The first difference is that a microprocessor is a heart of a computer system. A microcontroller is a heart of an embedded system. It does not contain the chips, I/O port or the timer. Whereas in case of a microcontroller, it contains the internal port and the timer. It is relatively slower as compared with the controller. As I have already told you that even if I have to read a single data, first I have to place the address on the address bus that is given to the external memory, and then that particular data will be placed on the data bus. Whereas in case of microcontroller, it is relatively faster, because whatever data or the code which is required is present in the microcontroller itself. I don't have to go outside. Microcontrollers are based on the von Neumann architecture, whereas the microcontrollers are based on the Harvard architecture. It is mainly used in making the computer. And it is mainly used to make a small device like the MP3 player. Now, we have learned about the difference between the microprocessor and the microcontroller. So, as per the syllabus, we are now moving towards the microcontroller. So, before going to the microcontroller, we should know what are the different types of the microcontroller. So, there are 5 major 8-bit microcontrollers which are used. The first one as the 3-scale semiconductor 68HC08 or 68HC11. The second one as Intel's 8051. Third one as Atmel's AVR. Fourth one as Xerox ZX. And the fifth one as PIC. We always call it as PIC. Long form of PIC as Peripheral Interface Controller from Microchip Technology. So these were the 4 major 8-bit microcontrollers. Now the question comes in our mind is that for any particular application, how to choose a microcontroller? Because these 8 are very close to each other. We can see that there are some features which are unique to one. So how to decide that this particular feature is more suitable for my particular application. So in this particular segment of the video, we are going to learn the criteria for choosing a microcontroller. Now these are the 5 major 8-bit microcontrollers which are used. Now each of the above microcontroller has a unique instruction set and register set. But one thing to note, and that is they are not compatible with each other. That means the program written for one will not run on the other. If I have written a program for Intel 8051, then it is not going to run on Xeon Z8, as both of these or all these 5 microcontrollers have different register set and different instruction set. So there are 16-bit, 32-bit microcontrollers made by the various chip makers. I have only listed the 8-bit microcontroller over here. So with all these different microcontrollers, what criteria do the designer consider in choosing the one? Because for one application, the need of that application will be a different one. So there are 3 major criteria for choosing the microcontroller, which we are going to see one by one. The first one is meeting the competing need of the task at the hand of efficiency and cost effectively. This is what the first and the foremost criteria, that is most important criteria in choosing the microcontroller. Now in analyzing the need of a microcontroller based project, we must first see whether we need a 8-bit microcontroller, we need a 16-bit microcontroller, or do we need a 32-bit microcontroller to handle our computational need effectively. Now, among the other considerations, we will see some of the more important considerations. The first one is speed. What is the highest speed that a microcontroller supports? Second, packaging. Does it come in a 40-pin DIP? DIP means dual inline package, or a QFP. QFP means quad flat package, or some other packaging format. Now why do I have to see what is the packaging? Because this is important in terms of space, assembling and prototyping the end product. Ultimately, it is finally going to decide what will be the size of my product. Now, power consumption. This is especially critical for battery power product, because sometimes I have to place my product at the remote location where it is not possible for me to give a direct supply. I am going to use a battery for giving a supply, or I may going to use a battery as an emergency supply. So I have to know what is the power consumption, the amount of RAM and ROM on the chip, the number of IO pins and the timer on the chip, how much it is easy to upgrade it at the higher performance or lower power consumption version. And the last one is the cost per unit. Now this is important in terms of the final cost of the product in which a microcontroller is used. I will give an example. For example, some microcontroller cost 50 cents per unit when purchased the 1 lakh or 10 lakh unit at a time. But if I go for purchasing the lower quantity, then the cost is going to be more. So I have to decide the cost per unit also. So that is also going to play an important criteria for choosing the microcontroller. Now the second criteria in choosing the microcontroller is how easy it is to develop a product around it. Now a key consideration includes the availability of a assembler, debugger, a code-effective C programming compiler, emulator, a technical support, both in-house as well as the outside the. So that is going to be required. That is going to be needed to be studied in more when I am choosing any kind of a microcontroller. The third criteria in choosing a microcontroller is its ready availability in needed quantities, both now or in a future also. For some designer, this is even more important than the first two criteria. We have seen the first two criteria as the first one as the choosing a microcontroller which is going to be more effective in terms of cost, and it is going to be efficient also. The second criteria was availability of the software, hardware development tools such as the assembler, debugger and emulator. But instead of these two, some designer may going to give more importance to the third criteria, and that is wide availability and reliable source of the microcontroller. Now currently a leading 8-bit microcontroller is a 8051 family that has the largest number of the diversified. Means what? A multiple sources are there, multiple companies are there who are giving the supply of a 8051. So sometimes in the case of 8051, which was widely originated by Intel, and several companies are also currently producing the 8051. So depending upon the availability, a wide availability, some may go for these kind of a criteria for choosing the microcontroller. References. For this segment of the video, I have referred the first book as the PIC Microcontroller and the Embedded Systems Using Assembly and C for Picketing by Mazdi and Rollin, and the second book, the 8051 Microcontroller Architecture, Programming and Application by Kinitaila. In the last segment of the video, we have seen 5 major 8-bit microcontrollers. From that list, now we are going to continue with PIC microcontroller. So in this segment of the video, I am going to introduce the PIC microcontroller. Let's start with the history of PIC microcontroller. In the year 1989, Microchip Technology Corporation introduced an 8-bit microcontroller called as PIC. PIC stands for Peripheral Interface Microcontroller. The Microchip Technology is the number one supplier of 8-bit microcontroller in the world. This microcontroller had small amount of data RAM, a few hundred bytes of on-chip ROM for storing the program, one timer, and few pins for I/O port, and that all on one single chip with only 8 pins. Microchip is number one supplier of 8-bit microcontroller in the world. They have introduced an array of 8-bit microcontrollers. From this list, let's see the 6 different 8-bit microcontrollers which they have introduced over the year. The first one as PIC-12, which is 8-bit and having the instruction format of 12 or 14-bit. The second one as PIC-14-000, which is a 28-bit and 40-bit instruction format. The next one as PIC-16C5X, which has the 12-bit instruction format. The next one as PIC-16C cross, which is a 14-bit instruction format. PIC-17, which is 16-bit instruction format. PIC-18, which is 18-bit instruction format. They are all 8-bit processor that the CPU can work on only 8 bit of a data at a time. Now, this particular PIC family are having one problem, and that is not all the 100% upwardly compatible in terms of software when going from one family to the another family. So what is meant by exactly this one? Now let's take one example. While 12 or a 16 PIC 1 which are having the 12-bit or 14-bit instruction format, the PIC 18 instruction is 16-bit wide with many new instructions. So that's why to run a program which is written for PIC 12 on PIC 18, we must recompile the program and possibly change some register location before loading it into the PIC 18. So I cannot directly run the program which is written for PIC 12 or PIC 16 directly on PIC 18. That's why the word, it is not 100% upwardly compatible. PIC 18 family has highest performance of all the families 8-bit microcontroller. And that's why throughout the unit we are going to learn about the PIC 18, which is the one with the highest performance of all the families. Now after learning the history of the PIC microcontroller, let's concentrate on the PIC 18 features. The PIC 18 has RISC architecture that comes with some standard features such as on-chip ROM, also called as a code, because on which I am going to store my program, a data RAM, data EEPROM, timer, ADC, USART, nothing but universal synchronous asynchronous receiver transmitter, and the IO ports. The size of the program ROM, data RAM, data PROM and IO port varies among the families. Also, the peripherals such as timers, ADC, USART, they are all available depending upon the family member. Reference I have taken this contained from the book PIC Microcontroller and Embedded System using Assembly and C for PIC 18 by Masdi and Rowling. Thank you for watching the video.